In problem number 9, we have another derivative of an integral defined function, and I'm going to do it both ways, the simple way, and then showing the long way, since we can find the antiderivative of sine of t in this case. So, from what we said before, the first thing that we want to do is we're simply going to replace in the integrand, we're going to replace t with the upper limit of integration. So that's sine of x to the third. And then we're going to multiply by the derivative of the upper limit, which is 3x squared. And we're done. So very simply, the answer is B. And you're going to see why that way is so much simpler than the second way that I'm going to illustrate here. So the first thing that we would want to do is to find the integral from 0 to x cubed of sine of t dt. Well, we know that the antiderivative of sine is negative cosine of t. We'll leave the negative on the outside, from 0 to x cubed. So again, we have a negative cosine of x to the third minus cosine of 0, and cosine of 0 is 1. So we now have negative. Negative, if I turn it around and write it as 1 minus cosine of x to the third power. So that is the integral. The next thing, though, we want is the derivative of that integral defined function from 0 to x to the third sine of t dt. And we now know that that's just the derivative of 1 minus cosine of x cubed. The derivative of 1 is 0. The derivative of cosine is going to be negative sine, so we want minus negative sine, which is positive. It's a chain rule. We leave the inside alone, multiply by the derivative of the inside, which is 3x squared. And we end up with the same exact answer that we had originally, but with much less work. So if you see how the process goes, you'll understand why it's okay for us to just take that shortcut. Just substitute the upper limit of integration for t, giving us sine of x to the third in this case, then multiplying by the derivative of that upper limit, derivative of x to the third, 3x squared, so we get 3x squared times sine of x cubed. And that does it for this.